I'm Kimaya.
And I'm Stephanie, and today we're going to talk about our app that we designed for people who are curious about the quantum world. We worked with UC Davis, the SJCOE Fab Lab, and we were supported by the National Science Foundation under grant number 2347866 and by the NWAI Hub.
We created our app using Scratch.
The app's target audience is everyone. It should be understandable to young audiences with minimal knowledge of computer science or to more experienced users.
This includes kids, adults, teachers, and more.
What does quantum mean, though?
There are two parts of the study of quantum that apply to our application: quantum physics and quantum computing.
Quantum physics is the behavior of small particles and probabilistic behavior.
Quantum computing uses quantum physics to make faster calculations and safer calculations.
Classical computing is slower and simpler calculations, and it's used in everyday items like laptops and cell phones.
Quantum computing is becoming more and more common. Companies like IBM and Google have made quantum computing accessible to everyday people.
Quantum computing has the potential to change all of our lives.
But how many of us are well versed in quantum computing?
We believe that there's not enough education about quantum computing in our school system today to prepare kids for the future.
That is the purpose of our app, to help people develop a basic understanding of quantum. And our app is called Quizzical Quantum.
Our app is broken up into three main parts: 2 classical computing models and a quantum computing model. We also created a fun host named Bob to guide our user through it. By comparing classical computing and quantum computing, our app gives the user a more comprehensive understanding.
Now let's show you a demonstration of our app.
Our app is available on the web or with a Raspberry Pi with a SenseHat attachment. The web version is accessible on any device that runs Scratch. When you first open the app, you see our lovely host Bob's explanation of what exactly this app is for. On the Raspberry Pi with the SenseHat attachment, while the model is looking for the code, it will be represented using the colors yellow and blue on the attachment. When your value is found, it will be displayed on the attachment using the corresponding colors.
You have to stop it. It was loading. And it kept getting out. I think it was
Hey!
Come on, stop.
Maybe we can just continue and cut this part?
We can keep going.
Okay.
Wait.
I think we're on here. Okay. So click yes.
Okay.
Then Bob takes us to our classical computing model part 1. In our classical computing model, you can click a button to switch the bit from 0 to 1 and vice versa.
The button is representative of how a bit is in a classical computer can either be 1 or 0.
Then Bob takes us to our next model, part 2 of the classical computing model, where you're able to choose a secret code. It becomes a fun interactive experience for the users.
The computer will then try to crack your combination the way a classical computer would, one combination at a time until it finds your secret code. Our computer model is actually testing combinations until it finds the combination you selected. This is the way a classical computer would operate.
Then we can move on to our quantum computing model to help contrast how the quantum computer and classical computer is different. Quantum computers use qubits, which can essentially be 1 and 0 at the same time. This allows us to test all the possible combinations for your secret code all at the same time.
But because the model is not a real quantum computer, it does not actually use qubits to find your combination. But we represent the use of qubits by showing overlapping 1s and 0s.
Using a quantum computer to find a combination would generally be much faster than using a classical computer, and we're able to demonstrate this through our models.
As you can see, our app helps highlight the world of quantum computing, and it's a great way for everyone to learn about the benefits of quantum computing and in what ways they could be so different.
Thank you.
Thank you.